Hello. Today I will show you scaling, that is feature scaling. It is required in many algorithms for machine learning. If we see the algorithms, that is a linear or a logistic regression uh, or support vector machines, lot of these algorithms need scaling. So what is the scaling? Suppose we have uh, many attributes or many columns in our data table, and one column values range from 10 to 80, another columns values range from zero point 0.2 to zero point 0.7 or 1000 to 8000. So there are lot of attributes with lot of varied ranges, and if we use these ranges as it is in our algorithms, they cause problem, or they're not tuned for that. So we have to convert all these ranges into range from 0 to 1, and that is called scaling. So scaling has a lot of different names, which is called normalization or standardization or Z-score normalization. So there is a lot of confusion, or we don't know exactly what that means. So I will try to solve that confusion today. This is a good source for feature scaling. That is a Wikipedia page, and it gives a lot of good formulas. So you can go through these formulas to know how that scaling exactly works. For our today's example, I'm showing this data. It is a 33 rows, two columns data. That is a lead exposure. One is exposed and one is control. So I will show scaling first in R and then in Python. So in R Studio, I opened RMD file and loaded the data. So these are first few rows of the data, and I plotted this data, expose as a and control as a B to make it simple for formulas. And with A and B, I got this plot. I'm showing this plot as a original data because you should know how it looks like after scaling. Once our original data is done, I scaled it between 0 and 1. So I want to just show that there are mainly two types of scaling. One is our scaling goes between 0 and 1. So after conversion of our data, all data lies between 0 and 1. So this is one type of scaling. And this is another type of scaling where the converted data has mean is equal to 0 and standard deviation is equal to 1. So these are main two types of scaling we get. There are other variations which I will show, but these are main two types. So this is our scaling with getting scaled between 0 and 1, so that it looks same. The distribution is same, only the scale is changed. Here 0 to 1, and on this axis 0 to 1. Here it is 10 to 70, and here is 10 to 25. So we change the scale with scaling, but its distribution remains same. Then this is another type of scaling where we choose two arbitrary numbers. I chose here 10 and 25, and I scaled my data between 10 and 25 on both sides. You can get formulas on Wikipedia page. Then this is normalization or Z-score normalization, where we get a scale between where mean is 0 and standard deviation is 1. I will just explain it. This is a R norm function in R, where I get normally distributed and randomly selected numbers or integers. I created 50,000 integers with mean 0 and standard deviation 1 and plotted the histogram of that data. So with that data, we can see the mean is 0 and standard deviation goes up to 3 standard deviations. with a rule of 67, 95, 99. So this type of data is getting after scaling of this type. So it is after normalization, so that we can see it range between -2 and 3 and -2 and 2 on this side depending on the data. But if we calculate mean of this data, it will be 0. And if we calculate standard deviation of data, it will be 1. So these are main types. And this is also scaling after normalization with another formula. So this is how we do scaling in R. Now I will show in Python. I opened Jupyter, I loaded data, same data that is expose and control level. I use matplotlib inline to show data plots inline in the Jupyter itself. I plotted the original data, which is same as we can see in R. Then I scaled it between 0 and 1. So there are a couple of methods we can use for this conversion. So one is normalize from pre-processing, and I plotted data which looks same, but the range is between 0 and 1. I can get same results with normalizer under pre-processing. So I fit transform that data with the scalar and plot it. So it is same thing here and here. Then this is another type of scaling where I get data converted between 10 and 25 as I have shown in R, but this is working in Python. So again, if we see the scale, it is between 10 and 25 on both sides. Then this is a robust scaler. This is not used that frequently. The only advantage of robust scaler is it reduces the effect of outliers. And this is a standard scaler where we get conversion of data with mean of 0 and standard deviation of 1. So this is 0 mean and standard deviation on both sides of the data on both axes. And this is again getting same thing, that is mean 0 and standard deviation 1, but with scale from scale method. And here we are using standard scaler. So there are couple of methods available to do same thing. So with this transformation, we can use data with either 0 and 1 or with mean 0 and standard deviation 1. So with this, you can get some idea how to do it. Thank you.